So we chose RoboSub for a variety of reasons. It's a really nice and open-ended challenge. It's really cool because you can go really deep into all the different areas. Controls, computer vision.
Putting a robot underwater is honestly a very complex task.
About 2 years ago, we kicked off serious construction on our first vehicle, Leviathan. We competed last summer, and this year we've been focusing a lot on refining the electronics and the computer science side of things to do even better at competition this year.
We got 15th out of 50 last year, where we were one of the best first-year teams, and we made semifinals, which was a big deal. That was our goal, and that was sort of our measure of success for last year. And so that also motivated us to get better so we can compete on some of the best teams levels this year and in following years.
So we've broken the project up into 4 main teams. We've got the mechanical team.
Last year, the mechanical team went through a full redesign of the submarine, making sure that we did not leak and that we were as light as possible, which are two very opposite design challenges. So we've got 8 thrusters on the robot, which allow us to move in any direction possible, move side to side, rotate quickly, control our depth and our tilt. This allows us to achieve any angle under the water that we possibly need.
We've got the electrical team, and they assembled the electronics inside.
The electronic team in general has upgraded the computer. We have added wireless networking in the form of a wireless router mounted on the robot. We've also added shielding on a lot of these wires to protect it from electromagnetic interference coming in from the motors and from the high currents that basically traveling through all of the wires inside the robot.
This is an autonomous competition, so it requires a massive amount of computer programming.
The qualification gate, the channel, and the buoys all require us to identify an object, identify the color where they are, and then perhaps navigate through them or to them and interact with them.
We've got a lot of sensors. So the big one, cameras. We use a lot of computer vision to locate things underwater.
Sensor fusion deals with how do you sort of use math and statistics to try and optimally combine all this information into like an estimate of where the robot is.
One of the other big obstacles is the acoustics.
So the painter challenge in the competition is that we'll have a painter which emits specific frequency sound wave that will be detected by us and processed to generate the bearing that will guide the bot towards that direction.
The final sub-team is testing, and they take the submarine up to the pool in the gym, plop it in there, and actually make sure it works.
Our biggest task this last year was supporting the software team in tuning a brand new control system that they've implemented this year. So that involved profiling every single one of our thrusters to see for what specific current or voltage input what the output would be. And it was actually pretty different for each of the thrusters, so that's really important to know when we're outputting to these thrusters to get to an exact point in the water.
Working with a team has been so exciting. I've learned so much about leadership and about managing a team, delivering a product on time.
I can't think of many better opportunities to learn real in-lab skills.
We've been able to solve some of these problems in novel and interesting ways.